Hello and welcome back to part 3 of the Delaware Tech Physics 111 Exam 1 Preparation and Practice Exam covering motion, also known as kinematics. In this section, we're going to talk about the graphing information. This is the type of information you can get when you plot position versus time. These are the x versus t graphs, or velocity versus time. These are the v versus t graphs. And then we'll just briefly mention some information if you were to plot acceleration versus time, but we don't do that in this course. Now you see there are headings on this graph. We have the type of graph, position versus time, velocity versus time, acceleration versus time. In the second column, it's what is displayed and what units. So this is what is on the y-axis, what is on the x-axis. The third column says the meanings of plus, minus, and zero values. In other words, for position, what does it mean to be positive? What does it mean to be negative? What does it mean to be zero? For velocity, the same thing, and for an acceleration, the same thing. And then for the position and velocity graphs, there's a column for the meaning of the slope. So when you calculate slope, what is that value equal to? And then only on the velocity versus time graph, you'll see in the last column, there's a meaning for the area between the x-axis and the plot. And we won't be discussing the corresponding value for the acceleration versus time plot. You're not responsible for that. Okay, so what is displayed? What are the units? Well, for a position curve, we have a y-axis is going to be position. Anytime you have a value, and pardon my poor penmanship here, anytime you have a graph where it's something versus something, the first something is always on the y-axis, the second something is always on the x. And you'll notice time is always on the x-axis. The x-axis, I'll try to make two dots a little bit better here than before. It's not letting me. The x-axis will be time. It's always time. And time is in seconds, and position is in meters, technically plus or minus meters. For the velocity curve, not surprisingly, the y value is velocity, and I'll just abbreviate it as velocity, and that is in plus or minus meters per second. The time plot is on the x-axis, as always. That's time in seconds. And then if you were to do that for the acceleration, it would be the acceleration on the y-axis. We don't do that. That would be plus or minus meters per second squared. So you'll notice the units, we start with plus or minus meters for position, plus or minus meters per second for velocity, plus or minus meters per second for acceleration, or plus or minus meters per second squared. It's a little hard to see the squared here. And then, of course, time is always on the x-axis, and that is always in seconds for these plots. Okay, so the meanings of the the meanings of the positive, negative, and zero value. For position, a positive value means the position's on the right. And for a negative value, the position's on the left. And for a zero value, and I'll write zero with a little slash through it to distinguish it from the letter O, it's in the center somewhere. For velocity, now we're talking about the values of positive, negative, and zero velocity values. Positive means to the right. It's pointing to the right. And these words here look a lot better if you look at the actual printed answer key. You'll see the words much better than I'm writing here. Velocity that's negative is to the left, and zero just means the velocity is stopped. It's zero velocity, no velocity. For acceleration, a positive acceleration means the velocity is going up, meaning it's going from some value to a more positive value. Negative means the velocity is going down, meaning it's going to a more negative value. And zero means the velocity is constant. It's not changing at all. And the meaning of a slope for a position curve, slope is the change in the rise, which in this case is a change in position, over the run, which is the change in the time. Well, that is the definition of velocity. And another way to say that in words is displacement, or change in position, over change in time. And you can think of change in time as just the amount of time. And you still have to take the difference between the final and initial values of both. For the velocity curve, the slope is the change in velocity over the change in time, and that is equal to acceleration. And we're not going to go into what it is for the acceleration plot. Now, the last thing that you do need to know is what is the area between the plot and the x-axis called for a velocity curve. So I'm going to draw a little example up here. Here's a velocity versus time plot, and let's say it goes up and across and comes down and over. We're talking about the area that's between the plot and the x-axis, this area. That area is equal to displacement, which we abbreviate as delta x, or we can just spell it out as the words displacement. And I've scrolled here down to the answer key so you can see the actual table with it, everything written neatly, and you can see all this information for yourself if you just look in your own answer key. But I wanted you to see this in printing that's a little bit better than my penmanship.